Okay, welcome all. Today we're talking about cannabis research. Here's some of the topics we're going to cover. So the subject of this first video is going to be cannabis and appetite. We're going to be talking about um, how cannabis can cause its effect referred to as the munchies, basically increasing how hungry you are and your drive to eat. So one of the ideas here is that cannabis is acting on the endocannabinoids normal control over the olfactory system. So olfaction and smell is a huge part of taste. So olfaction or smell is a huge part of taste. And when you smell something that's delicious, you start to drool, right? So increasing activity in your olfactory processes could drive food intake. And that's the idea that these researchers are investigating. Okay. So one of their first observations is that there's actually higher levels of endogenous cannabinoids or endocannabinoids in the olfactory bulb when fasting. And the idea here is that that's supposed to be driving eating. So the anandamide levels as measured within the olfactory bulb between a control animal and an animal that's been fasting, animals that have been fasting have significantly higher levels, right? And when you block the CB1 receptor using a viral model, meaning that they can basically block it from working in one specific part of the brain and only that, animals don't eat as much after fasting. So this is an hour after fasting and 2 hours after fasting. And while they do eat, right, they're still hungry, they don't eat nearly as much. So the idea here might be that while endocannabinoids aren't driving eating entirely, they're sort of promoting eating. Another way that the endocannabinoids within the olfactory bulb could be contributing is just actually by making food more rewarding. It might be making it more tasty. So this group of DeLuca et al., which is a different paper, you can see both of these papers online. They've both been posted within the class, within Brightspace. You're not required to read them, but if you find them particularly interesting and want to know more, you're welcome to. So endocannabinoids and THC could possibly make food more rewarding. It might cause more enjoyment as measured in these rats as by tongue movement and pollux. I think I've mentioned this before. They basically record the animal's face and watch how many lateral tongue movements they make and how many times they lick their paws. And more lateral tongue movements and more pollux is interpreted as more enjoyment, more pleasure, which is represented here as a hedonic score, or a score of how pleasurable something is. So they're looking at sucrose solution here, and sucrose solution is pleasurable under no drug influence or under a small drug influence. But when you have a higher dose of THC, you see a significant increase in the amount of enjoyment. Additionally, when we look at the levels of dopamine in the nucleus accumbens, so in these diamonds, what you're seeing is that they're giving the animals sucrose right at this point. They're pre-treating them with THC, right? So the THC in and of itself does increase the amount of dopamine within the nucleus accumbens, okay? So we do see that increase just from THC itself. That starts to drop off after about an hour. When they give the animal sucrose, that also causes a jump in dopamine. This jump in dopamine is blocked for both THC and sucrose when you apply a CB1 antagonist, which is referred to as SR here. We're going to see this in several experiments in this lecture. We also refer to this SR drug as rimonabant. It's a CB1 antagonist. So this antagonist totally blocks this increase in dopamine. Again, we can't directly say that, oh, changes in dopamine mean it's more pleasurable, but it is fairly well correlated with hedonic value. So it's possible that sucrose is just better. It tastes better when it's paired with THC. And CB1 is allowed to function when sucrose is present. Okay. So another way is that cannabinoids could be acting within the hypothalamus, right? So the hypothalamus is the part of your brain that controls your internal hunger signals. They're usually the thing that's like, hey, you're hungry, let's go eat. It's a big feedback system between your body and your brain to help drive those behaviors that help keep you alive. So the signals also tell your body that you're full, right? And the full seems to be correlated with lower levels of cannabinoids in the hypothalamus. So cannabinoid injections into the hypothalamus cause animals who are already satiated, meaning that they're already full, to actually continue to eat more. So this is the idea of like I don't need the food, but I'm going to eat it anyway, or I'm going to eat way, way more than I would normally eat while high. Okay, so when you have an anandamide, right, and again, we're doing a antagonist experiments here. So with no anandamide and no SR, this is the normal food intake, right? When you add anandamide, right, when you inject it into the animal, you get a huge increase. This is a dose-dependent effect, so a moderate increase will drive food intake quite a bit, and this is cumulative food intake sort of relative to body weight. And so very low is pretty normal. But if you drive the dose of anandamide even higher to 150, you still see an increase in food intake, but not nearly as much as you saw with the dose of 50 nanograms. When you combine anandamide with the CB1 antagonist, that effect is blocked, which suggests the fact that anandamide is actually acting on the CB1 receptor in order to achieve this effect. So it's possible that when you have THC, that's going to artificially increase the level of CB1 activity within your hypothalamus, and that could also be driving eating even when you're not hungry. Okay. And we can see this in normal endocannabinoid function. In this experiment of Dora et al., they were looking at how endocannabinoids regulate appetite, and they were trying to compare a normal chow diet. If you guys don't work with, rodents, basically chow kind of looks like shredded cardboard that's been put then into pellet form. It has all the nutrients that the animals need, but it really cannot have that much taste. Palatable diet is diet usually with a higher fat content that has a little bit more of a flavor. So you can see that animals prefer palatable food, right? So in each cycle, they have 2 days of chow, and then they're given palatable food. And in those cycles with palatable food, they consume way, way more food. They have the cumulative food intake is much higher. So the P phase is with palatable, and the C phase is with normal. So when they just have chow available, they eat sort of a normal amount of food. When they have palatable chow, they eat much more. Okay? When you block endocannabinoids and look at this palatable food, like it does influence the chow intake when you have high levels of the antagonist, meaning that CB1 cannot function. You're getting a pretty efficacious block of CB1 activity. You do see a decrease in the amount of food taken. However, when we compare that to what we see with palatable food, any obstruction of the CB1 receptor through this dose-dependent effect of the antagonist is going to greatly decrease intake. So it's possible that endocannabinoids have a real function and the CB1 receptor have a real function in regulating your appetite, and especially your ability or your drive to go seek out palatable foods. So, that's why it might be that it's not when people have the munchies, they're not going to eat salads, they're eating cookies, they're eating Taco Bell, right? So it could very possibly be that endocannabinoids through their functions in the hypothalamus, in the nucleus accumbens, and in the olfactory bulb could all be driving this intake of palatable food. So that is cannabis and appetite. Let's talk next about cannabis and addiction. That'll be in the next video.